Hi, and welcome to this section of the Advanced Calculus 2 tutor. And in this section, we're going to cover the topic of parametric equations, what are known as parametric equations. Okay, this section throws people for a loop sometimes because it's something you've generally never heard of until you get over in Calculus 2. You kind of wonder why it's taught at all. The dirty little secret is you don't use it that much, but whenever a system or something that you're studying in real life in engineering or in physics has a need for a parametric form of the equation, we're going to actually use them to do some problems like arc length and surface area and things that we've done before, but we're going to do them in parametric coordinates. So that's where we're going, but in this section, we're just going to simply look at some parametric equations and give you some practice with what they would actually look like, okay? So, in these problems, what we are going to do is two things. The first thing we're going to do is sketch the curve, okay? And the next thing we're going to do is we're going to eliminate, and I haven't even talked about this yet, but I will, some negative time, some positive time, reference to zero time, okay? Let's just go ahead and fill them in. Okay, so what we have is x, for x, it's going to be 1 minus t. So it's going to be 1 minus t, which was negative 2, and that's going to equal 1 minus a negative 2 is 1 plus 2, which is 3, okay? And then y is going to be 2 plus 3t, so it's going to be 2 plus 3 times t, which was negative 2, is 2 plus, this is going to be negative 6. So really what it's going to be is 2 minus 6, which is going to be negative 4. Okay, so it's 2 plus 6, which is 8. Okay, so I have a table of values and I can plot them. And all I've done is at every value of time, I have a corresponding x and y. So I have points, and I can plot those points, and you all know how to do that. So the next thing we're going to do is we're going to go ahead and graph this. Okay. Let me go ahead and draw a nice big coordinate system here, okay? Something like this. And this is x and this is y, just as it's always been, nothing has changed, okay? Now, let's look at this first value that we have. The point is 3 comma negative 4, okay? So what I'm going to do before solving for t, I'm going to have t is equal to 1 minus x. Okay, make sure you agree with that. Basically, you take this t, you move it over here. You take this x, you move it over here. So it's going to be 1 minus x. And I'm going to take this t, and I'm going to plug it right back into the other equation. So what I'm going to get when I do that is I'm going to have y is equal to 2 plus 3t, but this is what I've defined to be t, 1 minus x. Okay? 1 minus x. So let's go ahead and continue to simplify. Y is equal to 2 plus, distributing this 3 in, 3 times 1 is 3, minus 3x right here. Okay, and let's simplify here. Y is equal to negative 3x plus 5. This is the Cartesian version. Now, what does that look like to you? That's a line, obviously. mx plus b, this is a line. It has a y-intercept of 5, okay? A y-intercept of 5. Let's look back here. Y-intercept's at 1, 2, 3, 4, 5. It has a slope of negative 3. The negative means it's slanting this way, which it is, and it's sloping at 3. So you can see right here, you go up 1, 2, 3, x and y, just like I always do. Okay? Now at 0, my point is 0, comma 2. So it's right there. At the next point in time, x is equal to 1, 2, 3. But y is equal to 7. 1, 2, 3, 4, 5, 6, 7. So 3 comma 7 is about right there. At the next point in time, 12 and 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 12 comma 12 right around here. So this function looks like it bends over. It starts here at 0 comma 2 and it goes up. And it actually bends, I kind of missed my point here, but it kind of bends over because that point's right there. And it just kind of goes on like this and bends over, okay? So it's kind of one of these functions that bends over like this, and that's what it looks like. Now, how would you eliminate and find the Cartesian version of this by elimination? Well, you know what x is equal to, and you know what y is equal to, so it's a simple matter of solving for one and plugging into the other. So I'm going to pick x squared, and I'm going to go ahead and I'm going to solve. Should know that one. And the cosine is the same thing. Cosine of pi over 4 is square root of 2 over 2. Okay, now what's the sine of pi over 2? That's straight up and down pi over 2, so sine is equal to 1. And cosine of pi over 2 is cosine of here. There's no projection on the x-axis. So cosine of pi over 2 is 0. Okay? Now the sine of 3 pi over 4, okay,